So again, using our diagram here at the left and our knowledge of circles and right triangle properties, we want to find the missing measurements. So let's see, here we have our circle G. Here's our center, and we know a few things about it. We have our segment GT being 5 units, segment GU is 3 units, and we also know that DG is equal to GU, so they have the same measurement. So we'll mark that in our picture. So now we're asked to find the measurement for TU. So we see where that is, and that's part of a chord for our circle. We also can see that it belongs to the right triangle, TGU, where we know the hypotenuse and one of the legs. So knowing our information about right triangles, we could use the Pythagorean theorem to find that missing side, because we know the sum of the two legs squared is equal to the hypotenuse squared. So using our Pythagorean theorem, we could solve for the length of TU. Also, perhaps you notice that you've got this length being 3, this is 5, it's one of our triples, so this should be 4. Again, we would get that by solving our Pythagorean theorem as well. So TU is 4. Knowing that, let's see if there's other things that we know about our circle. So TU is part of the chord TR. And we know that we've got the right angle here. Well, GU belongs to part of the radius of the circle, GS. And since it's perpendicular to our chord, we know it has to bisect the chord. So TU should be the same length as RU, which means that it would be 4 units as well. Also, GU, we said, was congruent to GD. They are the same distance away from the center. And notice how they both end up at a chord, our chord CA and a chord TR. Because the two chords are the same distance away from the center, they must be congruent to each other. So if I know the length of this chord, I can get the length of this chord. Well, we already know that TU is 4 units and RU is 4 units. Same thing would be happening here with CD being 4 and AD being 4. So we have a total length of 8 for the chords. So we start labeling what we know in our diagram. We can fill in a couple things more for our table. So we know some lengths. We know that CD is 4. We said we also know the length of TR by adding the two pieces together, which would be 8. And CA, again coming from the two parts, 4 and 4 would also be 8. Now we want to work on finding the length of BD. And BD belongs to our segment BG, which happens to be a radius for the circle. And we already know the length of the radius of the circle is 5 because we're given a radius length here for GT. So knowing that from G to B is 5 units long, and we also know that from G to D is 3 units long, if we subtract that from the original length of the radius, we'll have the length of BD. Well, 5 minus 3 would be 2. Now I have to work on finding the length for SU. And so again, thinking about our picture, here's SU, and again it's part of a radius, SG. We know the radius is 5. We know a part of the radius, GU, is 3, so if we subtract 3 from 5, we end up with 2 as well. So again, the big takeaways for this problem was recognizing that all the radii in a circle are congruent, and that if a radius is perpendicular to a chord, it bisects a chord, and if chords are equidistant from the center, the same distance away from the center, they must be congruent to each other.